Hey everybody, this is Longo, and we are going to cover some 3D space vectors and the cross product. So you might be wondering what a 3D space vector is. Well, every graph that you've really done so far this entire year has just been on XY coordinate plane or a polar coordinate plane, but it's just on a piece of paper. Well, off of a piece of paper, our life is 3D. And you can actually plot points in a 3D space. And the way that works is your horizontal axis is actually now your y-axis. Your vertical axis is z because x is actually coming straight out at you. So it's hard to imagine, but pretend you're looking at the screen and that x-axis is your pencil and you just put it at the origin and it's just coming straight out at you, okay? So you can almost use the corner of your room, and that would be the origin, and one is coming out at you, and then one's going over to the right, and one's going up and down. That's kind of how 3 space works. So you can have vectors in 3 space. Instead of your AI plus BJ hats, you just add a CK hat to it as well. So to give you an idea of how it would work, of course, we start at the origin with our vectors. So this 2i would actually mean you bounce out towards you, like this is coming out of the screen at you, 2 units. The 4j means you would bounce to the right 4, and then the 6k means you would bounce up 6. Now, then you would have to imagine that that vector is actually coming out towards you. It's coming out of the screen in your direction, going right over your right ear. But that's kind of how it works. So the reason why we have that is because some of the things that we've been talking about so far, really, so think of the airplane from a previous video. You also have like up and down that can happen as well. So it's not just, going to the west with a wind going a little bit to the north. You also have like pressure going up and down and all of that stuff. So that's why 3D vectors are used. Now, just so you know, I'm not going to make a video on this part, but you can do position vectors with it like we did with 2D vectors. And you can do a magnitude, and you can do the dot product, and you can find unit vectors, and you can find the angle in between. And you would do the exact same thing. So last video was on the dot product, and we did A1 times B1 plus B1 times B2. Well, you would just have a C1 times C2 and you would just add them all together. So really, you do the exact same, like with magnitude, it would just be the square root of A squared plus B squared plus C squared. So same deal. So what we're going to do in this video is find a cross product, and that is the purpose of a cross product is to give you a vector that is orthogonal to both vectors in 3 space. And that, again, is going to come in handy with some physics and stuff like that. But all I'm going to do in this video is show you how to do it. And I will let you know there are different ways of doing it. So I'm just going to show you a way that I learned back in the day. And it kind of helps out. It's basically finding the determinant of a matrix. So what you're going to do is set up a matrix, and your top row is just going to be your I hat, J hat, and K hat, okay? And then underneath that would be your components of the V. So you would have your 1, 2, 3. And then underneath that would be all of your components of W. So that would be your 4, 5, 6. Okay, just made very easy numbers for you to see how this works. Okay, so this would be your V, and this would be your W. And what we're going to do is take a determinant of a matrix, and your calculator can do that, but I want to show you how to do it by hand just in case you ever need to know how to do it. What you do is you recopy the first 2 columns. So you would copy your I, 1 and 4, and then your J, 2 and 5. And what you're going to do is multiply 6 times. And I will use a highlighter to show you how to do that. What you're going to do is you're going to multiply down and to the right, I times 2 times 6, and then you're going to do j times 3 times 4, which is why we had to copy that row over, and then k times 1 times 5. And what that is going to do is give you 6 times 2 is obviously 12, so you have 12 I hat. And then our j, we're going to have 3 times 4, which again is 12 j hat. And then you're going to have your k and 1 and 5, which is going to give you 5 k hat. Okay? So once you multiply that way, so again, you can go up or you can swoop back around and go down. I've seen it done both ways. Really, it doesn't matter. Okay, so I'll show you again. You can now go back to the beginning and you can do your 4 times 2 times k, your 3 times 5 times I, and your 6 times 1 times j. But then I've also seen some people just come around and swoop the other way and go down that way. Honestly, it really doesn't matter, just so you know. So then you're going to just do it all over again. Now, you're going to have to combine your like terms, so just remember as you write this, if you want, you can do it in IJK order. So then you would have 5 times 3, which would give you your 15I hat. And then you have your j, which would be 6 times 1 times j, so your 6j hat. And then you would have your 8k hat. Now again, you could also do it in order. You could do 8k and then 15j, or I, and then 6j. The order doesn't matter because when you combine all of your like terms, you must use, you know, all of those old school algebra skills you learned. So we're going to combine our i's. 12 minus 15i is going to give us a negative 3 I hat. Then our j's, we have 12 minus 6, which is going to give us our 6j hat. And then our 5 minus 8 is going to give us our negative 3 k hat. So what we can do is check to make sure. But that vector is going to be orthogonal or perpendicular to both v and w. Now, if you wanted to test it, you can just find the dot product of v, and we'll call this one vector a. You can find the dot product of v and a. You can also find the dot product of w and a. And remember, that's just multiplying using the like terms. So this would just be, so if we wanted to check with this negative 3, 6, and negative 3, and we wanted to check it with v, all we would have to do is say negative 3 times 1 plus, and then you would have your 2 times 6 plus, you would have your 3 times your negative 3. And that's just multiplying the a1 and a2, the b1, b2, the c1, c2, just like we did with the previous dot product. And that would give us a negative 3 plus 12 minus 9, which gives us 0. Okay, so you can test it if you want, but it's not necessary. If you want to try it with w and a, you go for it. But I'm going to tell you right now it's going to give you 0. So that's how the cross product worked. This is Longo and I'm out. See you, bye.